Hello students, in today's lecture we are going to learn some new concept. Okay, so before we learn it, let us just look at this particular web browser. Here in the Google I have searched something like Rich Dad Poor Dad. Yeah, you guess it right, it's a book and it's a really nice book. I like it so much. So I'm just searching the different contents on it, and here what I found is a website on richdad.com. Okay, let me just go to it. So yeah, it opens the homepage of Rich Dad website for me. And if I go to this different pages, so if I go to the show and I just click on radio show, okay, fine, good. So it opens a radio show page for me. Now what I want you to understand over here is I have traversed many pages. Now I'll just go to the back button and click on the back button. It takes me to the Rich Dad homepage. Again, if I click on the back button, it takes me to the Google homepage where I just searched the book. What if I click on the forward button again? So now I click on the forward button. It takes me to the Rich Dad homepage. Okay, and again if I click on the forward button, it takes me to the radio show page which I just searched. Yeah. So no, something is happening that the Google is remembering my traversing pattern, or you can say this browser is remembering my traversing pattern in which I have traversed through. So I can go back and forward in the same sequence. So how is that happening? Who is actually behind this? Which technique are we using here? So it's a very small technique and very easy and simple. That is nothing but stack data structure. So now let us go ahead and understand this stack. So today the topic that we are going to study is stack. Okay, so let us start with it. In today's lecture, we will be studying the introduction about the stack and the different operations of the stack. Okay, so let us go ahead. When we see something like this, what is it called? Yeah, this is nothing but the stack of coins. Yeah, that means I can say there is something which is on the top. Okay, I can call this is a coin which is at the top of the stack, and this is the coin which is at the bottom of the stack. Yeah, so this particular stack of coins is following some sort of pattern which it follows. Yeah, and the pattern is like that. We can always keep a new coin. So whenever there is a new coin and we want to place the new coin, so we cannot place it in between. Okay, if we give this try, it will not succeed. We cannot place it in the bottom, it will not succeed. So new coin will always go in only one place, and that is on the top. Yeah, so that means every time you want to insert a new coin, you have to place it in the top. And when you want to delete something, you can also pick up any coins. So you can pick from the top. Okay, so we can place a new coin on the top and we can pick it from the top. So this is the main thing or the function that what stack follows. Yeah. So if you see the proper definition for stack in the understandable language, so here is the definition for us. It says, stack is called a last in first out, that is LIFO collection. This means that the last thing we added is the first thing gets pulled off. So if I say this particular thing is a stack and there is this top of the stack, so what will I push? That is what I'm adding is called as a push function. Okay, so last thing which I add will be the first thing to be pulled out, to be removed, or I say delete, and we call that operation as pop. So stack has two type of operations we call as push and pop, insert or delete. Okay, so it says it is a last in first out collection. So we have to remember this, that this is called as a last in first out. Why it calls last in? The one which is entered last is the first one to leave. Yeah, so now if we just remember the example which I told you in the beginning, that Google Chrome is browsing and it is remembering my surfing pattern. So how is that happening? It is maintaining two stack with himself. Back and forward are the two different type of stack it is maintaining. Initially those stacks are empty. Okay, so what is happening over here is whenever I'm going to first page, that is a Google page where I just search that book, okay? And then after that page, I go to the next page, and that was a Rich Dad home page. Yeah. After that, I surf and I got the page that is a radio show page, right? So now over here in this particular thing, when I'm at radio show page, whenever I keep on moving to the next pages, it keeps on pasting the link or pushing the link of the previous visited pages in the stack. So pehle Google page goes to the stack, then Rich Dad home page goes to the stack. Now after the radio show page, if I click on the back button, what should happen? It should show me the previous page. So what it does in that case, the radio show page will go to the forward stack, okay, and the Rich Dad home page will be removed from this back top. Yeah, this stack, it is removed Rich Dad home page, and then it is showing me this page. Again, if I click on the back button, so what should happen? Something should be pop out from the back array, back stack. So this green color stack is a back stack, and this Google page should come out. Okay. So what about this Rich Dad home page? It should go to the forward stack. Yeah. So the same thing is happening here. Rich Dad home page goes to the forward stack, and the Google page comes on the comes out of the back stack. Okay. So this is how, and again, if I click on the forward button, yeah, so I'm at Google page and now I click on the forward button. So it should show me this Rich Dad home page. So it will first push the Google page to the back stack. Yeah. So Google page goes to the back stack, and then the Rich Dad home page will come out from the forward, and I will see this page now. Now again, if I click on the forward button, then I can say the radio page should come out of the forward stack, right? So let's see that. Yes, so Rich Dad home page goes to the stack, and radio show page will come up. Okay, so this is how we can make use of two stacks, and we can toggle through the web pages, and we can go back and forward. So we have understood one of the real-time application areas where the stacks are being used. So isn't it really interesting? So let us go in more depth and understand how the stack is being used and how they are being used in programming languages. Okay, so this is some of the representation of a stack where we have different objects placed in a stack. If I am using an array, say for example, I have defined an array A of size 5. So in that case, I get an array from location 0 to 4. Okay, so if I have this first value which I put in the array, say for example, it is number 10. So it will go in the location of A of 0, isn't it? When I place the second object, say for example 20, it will go in the location number 1. So on, it will keep on doing that. So suppose, say for example, I have an array filled with 4 values. So my stack top will be at location number 3, and that's why there is a top variable which I am maintaining. The top variable value is equal to 3 right now. Okay. So now this is one of the example given here. Initially your stack is empty when your top is -1. When you push one element to the stack, that goes in the 0th location. Okay, so that your top is equal to 0 and stack of 0 will be having value 1. When you push next value 2 to the stack, now your stack top is at location 1. So top is equal to 1 and stack of value 1 will give you value 2. Okay, when you pop out something from the stack, we call this operation as pop operation. When we pop out some value, so now 2 is going to get popped out. So what remain in my stack is only 1. That's why my top is 0, and I will return the value 2, that is return stack of 1, which I have just returned the value 2 to the user. So in my stack, there are two different variables which I need to remember, top and max. Top is used to store the address of the topmost element of the stack, say for example 0, 1, 2 address location. And max is the one which will hold the maximum number of elements. Okay, say for example my array is of size 5. So I can say max is equal to 5. But how do I represent the stack in programs? Yeah, so I want to prepare stack, but I don't know how to do program for it. So here there are the options. You can represent the stack using arrays or using linked list. Okay, so let us see how do we do that. If I want to do stack representation using arrays, say for example, here there is an array A of size 10. So that's why it got the location from 0 till 9. And I can start filling the values. The first one which I inserted was 1, which goes at location 0. The next I inserted 2, 3, 4, 5. So now the topmost element of my stack is 5. That's why top value is equal to 4. So I can say array of 4, A of 4 is giving me value 5. Whenever the top is null, so that means if my top is null, or say top is equal to -1, so I can say my stack is empty. So that's what it says. But when your stack is full and your all the values are completed, so what is your top value? That time your top is equal to max minus 1. So now as I said, this array is of size 10. So my max value is equal to 10. So what is a max minus 1? 9. So when my top is equal to 9, I can say my array is filled. So if I have some values put over here, so in that case, my array top is equal to 9, and in that case, I can say my stack is full. Okay, so these are the conditions to check whether your stack is empty or full in array representations. Next is linked list representation. Linked list is a collection of various nodes. So I can say these are the different nodes over here. This blue color box, I can say it is a node. So in my node, I have the first element which is holding the data item, say for example a value, and the next is holding the address of the next node. So this way, the first one which I inserted in my linked list was 25. So it was a top at that time. Next I inserted 32, next I inserted 50, and last one which I inserted is 99. So if I want to remove something from the stack, I will remove from the top. That means 99 will get deleted now. Okay, so it will be popped out. When 99 is popped out, my top will be pointing to 50 and so on. So I am pushing and popping all the elements from the top of the stack. So this is a stack representation using linked list. Now there are various operations that you perform on the stack. So mostly the operations which are performed on the stack are called as push, pop and pick. Okay, so push and pop are one of the important these are the important operations. Okay, so let's see and the working of it. Now this is a small algorithm which is given to understand the push operation. Okay, so now here it says that the first we check I want to push some value to the stack. But before pushing, I should check whether all the values, if my stack is of size 4 and if all of them are filled, all the values are there, so then I cannot push something in my stack. So I have to check whether my stack is full or not. So I will check this condition. If top is equal to max minus 1, yeah, say for example, if this is an array of size 4, so there is this memory location of array. Yeah, so the memory location of array will be from 0, 1, 2, 3, right? So if top is equal to max minus 1, the stack is already full, so I will give overflow message and I will stop inserting a new element and I will come out with from the function. Well, but if the top is not equal to max minus 1, then I will go to step 2 and then I will try adding the new value. Say for example, my array is of size 5. So there is one more block remaining. So what I will do now the if condition is false and now I go to step 2. Here I increment my top by 1. So my top was earlier 3. Now my top incremented by 1. So top is now pointing to 4. And at this particular location, I will now put the value, that is stack of top, that is stack of value 4, is stack of 4 is a new value. New value I want to insert is 50. So that 50 will go at this particular value. And then I end. So here the statement says the push operation is used to insert the new element at the topmost position of the stack. If top is max minus 1, then stack is full. We give the overflow message. And if we try to push on to the full stack, then we'll get an error message saying it is a overflow. Okay, so this is about the push operation. Let us see the next operation. Now we see the pop operation. Pop operation is the one in which we are going to remove something from the stack. So it is used to delete the topmost element from the stack. First of all, we'll check if my stack is completely empty. I cannot delete anything from my stack. So if I have a stack but my top is currently is equal to -1. So if my top is equal to -1, that means there is nothing in my stack. The stack is empty and I cannot delete. So if top is equal to null or it is -1, we say it is a underflow. Okay. If not, that means I have some values in my stack. Say for example, there is 10, 20 and top is pointing to the topmost value. Okay, so your top is equal to 1 in this case, and now you go to step 2. So step 2 says take a variable val and save your value of stack top in that. So what is a stack? What is a top actually? Top is location number 2. What is stack of 2? Stack of 2 is nothing but 20. So 20 I am storing in variable val. Now I just save the value which I am deleting, that is top 20 in the val variable. Now I can delete from the top. So I'm deleting, that means I'm bringing my top variable down. So top is equal to top -1. So that means now your top is pointing to 10. That means your top value is 0. Yeah, this way we delete from the pop out from the stack. Okay, but if your stack is empty, then in that case you get an underflow message. Next is a peak operation. Peak is almost same like pop operation, but the only change we are doing is we are not removing something from the stack. We are just checking what is the top value right now, and we are not doing anything. We are not inserting, we are not deleting. We are just checking the topmost value. But in that also, it will have to check whether your stack is empty or not. Okay, so it will first check whether your top is null, if any, nothing, or -1. If nothing is there in the stack, we will give the stack is empty. And if nothing is there in the stack, we will simply give the stack is empty. And if the condition is false, then we go to else condition and we go to step 2. Here we will return the stack top. So whatever is there in the top of the stack, we simply return that value, but then that value is not deleted. Like how in pop operation we deleted this 20, here we are just displaying 20, but we are not deleting. So your top is still pointing to 20. Okay, so this is what about all the three operations, that is push, pop and pick. Okay, so here also we'll check this stack empty conditions. Okay, now there are some real-time applications of stack. These are the some few which I have listed. There's a list, huge list of it. Okay, we can use it in undo operation. Whenever I'm writing something in a word pad and I have written something wrong and I want to undo and go back to the previous case, so there also we are using stack. We are using for syntaxes that we are writing here. Okay, so in parsing using stack, we are using in a virtual machine, that is JVM. We can use in forward backward surfing in browser. There's the same example which I've just shown to you all. To check the history of all the visited websites, also we can see the stack. In fixed to postfix string conversion. So this is something which will come in your syllabus also when you are studying data structures. So string conversions and evaluation, there also we are making a big advantage of stack. So it's a really very useful data structure if you want to learn. Okay, so this video is covering only stack and the operations of stack. To know more about the how to program in stack and how to do the operations, okay, so we will go and watch the next video. Thank you for watching and do subscribe for please more videos on the same topic. Thank you.